Our next presenter has been a developer for over 20 years. He is one of the original developers involved with OpenStack. And after leaving the proprietary software world over a decade ago, he has been primarily a Python developer. He has spoken at several US PyCons. His main focus these days is with free and open software, and he's going to teach us how to build our own infrastructure with Python. Please join me in welcoming Ed Leafe.
Well, thank you. That was a very nice welcome. And I also just wanted to start by saying that I've been to 10 US PyCons, I've spoken at a few of them, and I've always gone back because that's been like the highlight of my year. Not just the technical content, but the sense of community you get, sharing ideas and things with people is unparalleled. And this is my first time both in Australia and at PyCon AU, and I got to say I've had a great time. It totally rivals everything in the US PyCon. So thank you guys for having me here. All right, so I just want to start. He gave me a little introduction, but I guess this isn't going to work. Oh well. Who I am and why I'm standing up here talking to you. I work for Rackspace. I've been a Python developer there for about 5.5 years, worked on a variety of things, but one thing I was most fortunate to work on was OpenStack, and I have the bag to prove it. It's one of my favorite pieces of tech swag. It's OpenStack Founder, and that's actually a little inaccurate. I actually worked on OpenStack before OpenStack existed, because I was on the Swift team before, while it was still a proprietary Rackspace internal project that we then open sourced when we created OpenStack. And currently, I maintain the PyRax SDK for OpenStack clouds. It did start out as a Rackspace-specific SDK, and hence the name, with the racks in there, but it works fine with all of OpenStack. So here's the situation that all developers seem to find themselves in at some point. You know, you have this great idea, and you grab your software, you start pounding away, and you come up with this awesome idea, this awesome app for that idea. But now you have to get it out there. You have to deploy it. You have to set up an infrastructure so that people can come and use your app. So this is the part that I don't like to do. I love writing software. I hate dealing with hardware. You know, do you know how many software developers it takes to change a light bulb? None. It's a hardware problem. But anyway, at some point you're going to have to do this. You're going to have to set up an app server and maybe a database for your app to talk to or whatever, and all the internet can now come and use your amazing application. And since it is amazing, pretty soon you're going to start pushing that server to its limits. So you come up with something a little more robust with throw a load balancer and a couple of server instances there. And, you know, again, it keeps growing, getting successful, so you do the horizontal scaling there. And this works great, except that every time you do this, you need to buy another server, rack it, cable it, install the software, install all the updates, install your application, install all its dependencies. So you end up doing something where you can either mirror the disk image, or I've done it with rsync, you know, to kind of keep these all together. And you also have the issue that when your app is updated, that you have to now update all these servers to keep them all in sync. And, you know, you may have state-of-the-art hardware like this, but what happens is that, you know, you do have to connect it all together, and so you have this dream of, you know, this perfect setup with all this beautiful cable, but after you've had to make a few changes, you know. And I do have to say this was not taken at Rackspace. Our data center don't look like that. Okay. So this is where the cloud comes in. This is where, you know, the power, the attraction of the cloud is that you don't have to do all of that stuff. You know, you can if you have your own data center or server closet or whatever, or your provider, gets the hardware, gets a bunch of it and configures it in advance, installs OpenStack on it so that it can work as a cloud, and now when you need new resources, you can provision them dynamically. And as it grows, you can add more hardware to it, more compute nodes, more storage, more whatever, but that's isolated from the developer. You don't care. You just have this cloud that you're talking to. And I know Tristan did a thing at the OpenStack mini-conf the other day where he provisioned a network very similar to what I just showed you by using the control panel and creating a network and some servers and connecting them all together. But I think what the real power of it is that you can do it programmatically. And since this is PyCon, we're going to do it with Python. So this, to me, is the big thing for being able to work with the cloud programmatically provides, and it's all due to APIs. APIs are the lifeblood of any system. So, but the thing is that they're very low level. They're the least common denominator. They work down at the guts of the system, and then you build on top of those. So they end up being extremely powerful. But when you have to work with them, it gets to be kind of a pain. So I kind of summed up what one single call requires. The first thing is authentication. You have to make sure that you identify yourself to your provider. You have to be able to cache all this because you can't keep making authentication calls before every request. You have to be able to recover from errors. You have to format your requests properly with the exact headers in the exact format that the service requires. You have to be able to tell with some errors which ones you can recover from, which ones you have to just give up and bail out. Oh. Sorry, I don't have any audio visual for this. And then when you get the result back, it's something basic like JSON, and then you have to parse that and then create objects that you can then use inside of your application. So it's a lot of, and this is for everything. Everything you do, you have to do that. So most people, when they have to start working with an API, write all that scaffolding that they have to do, make their call, and then do all their parsing and the result, and I got it to work. And then they go to make another call. And they go, I don't want to have to write all that again. I know, I'll refactor. So they refactor that out into some abstract API calling method, and then the individual methods just figure out what data they need to send or what URI they need to hit. And now you're kind of building an SDK yourself. So here's the thing that kind of is a temptation a lot of programmers fall into, is reinventing the wheel. So here you're using something like an SDK that has been tested and used by lots and lots of people, and you think that you're going to write something that's going to be as good or as robust or as stable as that. Good luck. So that's why I think using an SDK to do this stuff is the way to go. And this is where Pyrax comes in. It's the Python SDK for OpenStack clouds. It not only has the Python module for talking to all the cloud services, but it also contains documentation, sample code, all that good stuff. Because, it's great to have APIs and documentation documenting every single call, but you ever start a project and you're like, what do I do first? How do I do, am I doing this the best way? Is this the ideal way, or am I doing it some really obtuse roundabout way that, makes me look silly to anybody else? So at least get you started with sample code and things like that. And of course, it's up on GitHub. And you can go there and love to have pull requests. And the other thing is that this is pretty much, I've been the main developer on Pyrax, but if I were to get hit by a bus or marry some rich woman who wants to just take care of me or something like that, where I decide that spending my days working on Pyrax isn't the best use of my time, you're not going to be stuck with some orphan software. We have dedicated to supporting this. This is an integral part of our business, so that's a good reason to go with something like that. Now, one of the things, I hate going to a technical conference and it's just some guy talking or some girl talking that, you know, we're developers. We want to see some code. So I'm going to switch over. Now I have the code here, but I'm not going to go through it now. What I'm going to do is I'm going to run the script. I have a script written that's going to go out. It's going to basically create that little diagram that I have. A database, 2 application servers, behind a load balancer, and configured with DNS. Now the thing is that building this stuff, the images that we use take time to build into an active state. So I'm going to start this, then I'm going to go on with the talk. So let me just get that going. And I just want to watch it for a second, because every once in a while, network hiccups, I've gotten burned before, so I just want to make sure it's running. The other thing I wanted to mention is that when you create your first cloud server and you get it configured and you get your application and its dependencies installed, the nice thing is that then you can take a snapshot of that. It's called a server image. And then when you build new servers, you can build it off that image. So when they're finished building, they're in the exact state you need. You don't need to do the installation. You don't need to run. I knew it. What did it want? Yep, a 400. Let me make sure that I have a working internet. Of course it worked. Yeah, that's working. Okay. Let's try that again. The demo gods aren't always on my side. All right, so anyway, what I was saying was that you can have an image, and then you can, as you need to expand out horizontally, you can create new instances based on that image. And that's great, but what's also kind of cool is your app is going to need to be upgraded sometime. You're going to add new cool stuff to it or whatever. And how do you go about updating your system? Well, what you can do is take your existing image, make an instance of it that's offline, apply your patches to it, test it, make sure it's working, and then start building instances, adding them to the load balancer from that new image. And if you're smart, you'll name your images based on your release numbering system, so you know which one is which. And then you can start seeing some of the traffic hit those. And if you can keep an eye on them, if there's any errors or whatever, you can just delete those instances and just leave the old version there. If it does work great, though, then you can just delete the old version instances and fire up new ones of your updated version. And so you have zero downtime, you don't have any disruption, and it's really great if you're doing continuous deployment, because that way you can do a quick test, start deploying. If for some reason you get it out there and there's a major bug, okay, it's building now, good. Phew. I don't like having to vamp up here while my computer decides not to behave. But anyway, so these images are a powerful way to install, not only to install your application, but to update it and maintain it. So this is the code that will be at the top of your script, just the import statements. And then the first line is where you do your authentication, and it's method keyring auth. If you're not familiar with keyring, it's an operating system level way of storing encrypted passwords so that only the currently logged in user can access those passwords. It's probably the safest way to store credentials and stuff like that on your system. So I have it stored up, so that's what I use. You can also keep them in a credential file if you choose, if you're on a secure place and all that. And you just call set credential file and with the path. Or if you're doing interactive, you can just say set credentials and pass your username and password. These all do the exact same thing. What they do is they go out to your identity service, authenticate, get back the token, store all that information, get the service catalog, which gives you the endpoints for all the available services on the cloud, and then creates Python clients for every one of those services. And the credential file just looks like that. Right now, built in, we have support for standard OpenStack authentication, Keystone, or Rackspace Cloud. One of the nice things about OpenStack is you can plug in your own authentication system. You don't have to use the built-in one. So if you have an existing system, like we had our own global auth system, some people might have an LDAP or EDIR or something like that, that they can tie into that and use that for authentication. And it works great. This is the main configuration file. You can set all this programmatically. I just find it so much easier to create a configuration because I have to work with multiple systems. My test environment, my production environment. I've worked with a DevStack thing to make sure it works with that. I have my personal account, not my Rackspace test account. So this, is a standard configuration file, and you can define different environments. And if you notice, the third line in the default section says region. And what it does is OpenStack has this notion of data centers that are grouped together are called a region. And Rackspace uses the airport code closest to where the data center is. So this one is set up to use our Dallas data center. DFW is Dallas Fort Worth. But for you guys, I'm going to make a little change here. Much better. As of last month, we now have a data center in Sydney with a full cloud capability, and I did some timing when I first got down here, and it's a lot faster than having to do everything hitting the States, so. All right, and if you look at the code, you're going to see a bunch of abbreviations. I get tired of typing long things. Even with auto-completion, I like having short little things. So when you see these things, when you see CLB, that's Cloud Load Balancers. And these are the clients that you use to talk to the different services. So the first thing you do, just to create a database, you have cloud database.create. Pretty simple. You pass a name, a flavor is a RAM configuration, and a volume of 2 gigabytes. And so that'll create an instance. Right now they're MySQL instances. We have Postgres and MongoDB in the works. Now this next one is, you'll see this a lot, wait for build. What it does is this, a very common thing is you create it and it goes out and it's asynchronous. So the server exists or the database instance exists, but it's being built right now. It'll have a status, if you query it, of build. So you want to wait until the thing is ready before you start acting on it. You can't interact with it when it's still building. So you pass in the instance and whether or not you want to print out the status. That's what you're seeing in, oh crap. Well, let me scroll up. All right, see up at the top here, that's what the wait for is doing. I got to the app servers and it built. It was in build and then it just crapped, I don't know. And we only have 10 minutes and it takes almost that long to run, so I do have a nice little cleanup script because this does happen a lot. Where was it? Oh, the wait. The other thing is it'll block until it reaches the build is complete. There's also a non-blocking version. You just pass in a callback function and then it'll continue on non-blocking and then call that callback when the build finally completes. So depends on what your need is. All right, I'm going to give this one last try. If not, you can, throw rotten fruit at me or whatever. Let's make sure. Okay, that's starting. All right, so once the database instance is there, you create a database in there and a user who has access to that database. So the code is pretty readable. I mean, it just tells you what you're doing. This is how you create an isolated network. So if you want to have a local LAN that's private among your instances, you just define a name, CIDR, address range, and call cloudnetworks.create, passing in that information, and you have yourself a private network. You can also store public keys in there and name them so that then when you create your servers, those keys will be installed on there so you can shell into them directly. And so it's just cloudservers.keypairs.create, passing in a name and your key. So this is the code that actually creates the server. You can see the hard-coded UUID of the image that I created. The app that it has is just a simple Flask application that when you hit it will give off the IP address of the server and the current time, just so you can tell which one is being hit. And here's how you create a server. You just give it a name, the image, flavor is a RAM disk combination, the key name, and which networks you want to install. And I just had the service net, the local one. And same thing for a server too, and then you wait for those to build. Now once they're built, you can query their network information, including their IP addresses. So once I get those, now I can define a couple of nodes for the load balancer. And I want them to listen on port 80. I can also give them a weight, so if I have different size resources, I can give one more to one. If I have a test system, I might want to give it a higher weight so that it will get hit more often and I can see the results better. Then I create a virtual IP instance, and most of the time this is all you need if you're just setting up a public load balancer. There is provisions for doing them behind private LANs, and it's all documented. If you're interested, you can look at that, but it's not really what we care about right now. Here's where you create the load balancer. You just, again, give it a name. Specify the port and protocol, the nodes you want to have, the virtual IP that it's going to use, and the algorithm. Weighted round robin, it just allocates to all the different nodes based on their weight. And again, we wait for that to build, and then we grab its address. And that's the public IP address that people are going to use to reach your application. Now, I actually have the domain name pyraxdemo.com, so what I'm going to do is I can create a domain using our DNS and give it a time to live of, what is that, 5 minutes, 15 minutes? Create an A record with that domain name and add that record to the domain, and I got DNS. And that's basically it. I just created that. Now, because I'm talking and explaining, it took longer to explain it than it did to run, if the thing would run. Oh, it's still going. This is going to take probably a few more minutes to build. When it's done, it'll print out the IP address, and you'll be able, if you have a browser available, you'll be able to hit that and see that it's actually working. And it'll take a while for the DNS to propagate, so maybe like in 10 minutes or something, hit pyraxdemo.com and you should be able to hit that. All right, while that's running then, that's what I have, and let me just have adding another node. We can skip that. We can take questions now, but before I do, I just wanted to point out you can reach me either at ed.leafe@Rackspace or just ed@openstack.org. And I'm on Google and Twitter, and just my name, so
we have a fair amount of time for questions, so let's see some hands. Oh, no. Thanks very much for those hands. Now let's see the hands for questions.
Sure.
Does Pyrax have methods for like actually installing the software and
sorry, I have to apologize. I have really crappy hearing, and this is kind of an echoey room, so maybe I'll come to you. How's that? All right. What was that?
What methods are there for actually installing software and customizing your instance within Pyrax?
All right, there's two things that you can do. One, you can specify files that are uploaded, but they're fairly limited in what you can do. A lot of them, they use it for, like in /etc or something, some configuration in there. You can install huge amounts of software, but once those servers are created, they're just like any other server. You can shell into them and open up a terminal session, and, you know.
Thank you. My company, the one where I work, we're already customers of you, and this looks so much like what we do that I feel, like I'm doing the right thing. But I have the question that we actually build generic Linux machines and then run around MySQL instances on them. Mm-hmm. What are the advantages of creating DB instances of Rackspace? What is it that you give us that we don't then have to do it by hand?
Okay, well, with the cloud databases, there's a couple of things. One, they're in the data center right next to your cloud instance, so the latency between them is very short. Two, they just finally, and I can criticize them because it's my company, finally got cloud backup installed in there. So you also have the backup built in, and the backups go automatically into Swift, which is the object storage, so you have the redundancy and all that in there. The other thing is that if you have a database there and you start to run out of disk space, you can just resize that instance and presto, you got more disk space. So you have, those are some of the advantages. So.
Thanks. You mentioned that Postgres is on the way. Have you got any projection?
Say it again, I'm sorry?
Postgres is on the way. When?
No, I really don't. I'm not working directly with that team. I expect it to be within the next 2 months, but don't hold me to that, all right? I just know the general cycle, and I'm just kind of guessing, educated guessing. Okay, all right?
Pyrex looks really good, but I'm using some of the other cloud providers which don't have a nice OpenStack interface. Is there anything that kind of abstracts away OpenStack versus EC2 versus Compute Engine versus like other?
So yeah, so if you're using Amazon or one of the other providers that are not open, and by the way, I don't know if you saw my t-shirt, OpenStack, free as in beer, speech, and love. Okay, yeah, we made a conscious decision to work with OpenStack because we think that's the future. We think that's where things are going. We do recognize that other people are using other things. We do have a product called libcloud that we maintain. It's another Python library that is cross-provider, so it works with Amazon, it'll work with Rackspace, it'll work with HP, So that's an option too. Libcloud is not as finely tuned to OpenStack-based systems, though. It's more of a least common denominator approach. So it's really great for firing up instances and storing objects, but, okay.
So if I wanted to have an HA system and I wanted to have a backup data center, can I use Pyrax to just pass in like a flag saying, create an HA for me?
Say create. I missed the first.
High availability with, like, let's say I'm creating a data center using Pyrax, and I want to create a backup data center somewhere else.
In a backup? Oh, yeah. So you can, there's some methods that I didn't show called connect to whatever, cloud files, connect to cloud servers, and you can pass in a region. So you can work with multiple regions at the same time, so you can move between them and all. For this, I just figured one is enough, so. Oh, did this thing already disconnect? I just wanted to see if it actually finished. Oh, I see. It went to sleep. Sorry. No, it crapped. Oh, well. You can throw the rotten fruit now. Come on.
Anyone who doesn't have rotten fruit? Oh, there we go. There's a question.
Yeah.
Sorry for putting on the spot, Ed. Do we, just to carry, I'm a racker also, but do we have any plans to extend Pyrax either with heat from OpenStack or the deployment stuff that was recently announced?
All right, sorry. I have to keep apologizing. It sucks, too much loud rock and roll over the years, but what was that?
Do you think Pyrax will be extended to work with heat or any of the deployments stuff that we recently announced?
Yeah, oh yeah, and there are definitely plans for that.
My question that they asked about the software, I was curious.
Oh, okay. Yeah, no, it's definitely a work in progress. I have just put the finishing touches on cloud monitoring, and I just have to write all the documentation, and all that. So it's one of those things that it forces you to write documentation, which is not my most comfortable thing, but it's one of those things, it's like exercise. It's good for you, and anything that encourages you to do it is a good thing, so.
Time for a couple more questions.
Oh, damn. Auth system, no.
No worries.
I have no idea why it's doing that. Oh, well.
Well, Ed, as demo compensation, here is a blend of Norwegian Blue coffee for the conference and the PyCon AU mug to drink it in. Please join me in thanking Ed Leafe.